So, good evening. Am I on mic? Yes, sounds good. So, masters, members of the livery, ladies and gentlemen. My name is Audrey Canning, the Master Engineer, and I'm absolutely delighted to welcome you to the Guildhall tonight, this evening, to discuss the future of air vehicles. I'd especially like to extend a warm welcome to my host masters, so the Master of the Scientific Instrument Makers, the Master and the Immediate Past Master of the Air Pilots, and actually a very, very special welcome to our immediate past Master Peter of the Engineers, who's only just rejoined us from a rather nasty bout of COVID. And of course, not missing out our expert panel, so thank you all for being here. So the UK aerospace industry, is the second largest in the world. It's a high-performing, high-productivity sector worth almost 33 billion. It's a key driver of our manufacturing sector, which in itself is worth over 400 billion, representing 15% of the UK GDP. In 2011, the Advisory Council for Aviation Research and Innovation in Europe, ACARI, set the Flight Path 2050 targets of achieving 75% reduction in CO2 and a 90% reduction in NOx emissions by 2050. In addition, they required that aircraft are designed, manufactured to be recyclable, as well as to make use of sustainable aviation fuels. Over the last decade, the aerospace sector has followed some very ambitious plans, resulting in a reduction of an average fuel burn per passenger of nearly 3% per year, although this has not been sufficient to compensate for the growth and demand of air traffic over the same interval. And then the pandemic hit. It grounded more than 50% of the aircraft overnight, severely disrupting investment plans of some of our biggest multinationals. And this has been compounded by the social pressures to accelerate the move to net zero, a drive towards greater automation in the form of drones and air taxis, a drive for clean and renewable energy sources, as well as onerous regulatory requirements. In short, the investment in the aerospace sector is experiencing massive disruption, opening up opportunities for new entrants and bringing both high-risk and high-reward investment opportunities. So tonight we will hear from some of the key players in this critical UK sector and explore some of the ways forward for the future of air vehicles. So you really have a hearty welcome, especially to our panel, and I hope we have a wonderful evening. Thank you.
So my name's Jenny Boddy. I'm a past president of the Royal Aeronautical Society, but worked for all of my career really within Airbus, with some background. Probably when I had a proper engineering job, I was doing avionics and safety critical software, but went right on through to managing the Airbus portfolio of R&T in the UK, particularly working with UK government and developing the support for particularly research and innovation carried out by Airbus in the UK, not only Airbus, but the whole of the aerospace sector. I'm really delighted to be here because I think it's such an interesting and exciting thing to be talking about. When we were first talking about being involved, and Audrey sort of said, so what would you be talking about? And I said, I should probably know on the day, because so much is changing so quickly in this field. And so many things, even in this the last few days, there have been announcements that are potentially relevant to the way forward. I thought it might just be worth mentioning just a few things. I see the Roland Berger report is a sort of a regular update on things aerospace and space, and they've identified 300 electric personal aircraft projects taking place in the world at the moment, which is massive if you think about where we used to be maybe only 10, 15 years ago, 20 years ago. Something that I'm also concerned about and very aware about is the whole complex landscape of certification. And innovation isn't enough unless it's proved and demonstrated. And when we really look at the certification, it's not only project certification, but it's also organisational approvals and the those of us in bigger companies will know about the design organisation approvals and those sorts of things. And it's also looking at authorities and who's actually going to do the work, because of course up until relatively recently, I won't mention the B word, FAA and EASA were there, well manned up, well populated to be doing the work. Potentially projects that are going to take place in the UK, it's going to be the CAA. So they're having to not only resource themselves to do the work, but also it's all in a very new area. So I think that's quite a challenge. I think something else that I think that's very interesting, and I've been talking to people just before about the new startups, the new companies that are getting involved in this space. So interesting. People we never even thought would have been involved in aerospace related projects are now getting involved, which is fantastic. And I think what's also interesting is seeing how the relationships coming between the big players, whether it be Airbus, Boeing, Rolls-Royce or whoever, and some of these smaller startup projects. And I just hope that the little people don't get swamped by the big people in this game that's playing out. And probably I think the last thing, which we're not actually going to talk about, but it's good to have in our mind, and it was something else that was in the paper this morning, is about infrastructure. And I think there's two sides of the infrastructure. I think I heard this morning talking about customer-centric vertiports. Doesn't that sound wonderful compared with the awful queues that you have when you want to go flying at the moment at the major airports? Is some of the stuff we're talking about actually going to be an alternative to road and rail? Can we really see that happening? But then I think it's infrastructure. We're going to hear a little bit about hydrogen and the use of hydrogen. What about the infrastructure for providing hydrogen to the airports or the refilling stations and whatever? So I think there's some really fascinating stuff. So we've got it's quite a busy programme, and it's also quite a short programme, because I think it's really important that you get to ask the questions that you want to ask of us. Well, hopefully it's of them and not me. But so we're going to move into 5 presentations. They are quite quick, and I'm going to be quite rigorous on the timekeeping, or else we won't get to. The target is that by about 7:10 we can open up for questions and answers. So I'm not going to introduce the people other than by their name. They have got the opportunity of doing a very brief introduction to themselves, but really, obviously, what we want to hear about is what they've got to say on their particular topics. So I'm delighted to welcome Gary Elliott from ATI, talking about the air vehicle landscape. And I've got the important job of operating the slides. Yeah. So there we go. Shall I go straight on?
Yeah, thank you, Jenny. And good evening, everyone. Nice to see you all. Some friends and some new faces. So very much looking forward to the conversation. In terms of my background, so I'm Chief Executive of the Aerospace Technology Institute. I started as an aerospace engineer many years ago, went to Queen's University, spent nearly 10 years with British Aerospace, which was then British Aerospace up in Wharton, and then ran a number of companies throughout the UK before moving into banking. So I've had an unusual mix of engineering and banking. Some may say good, some may say bad, but and I then ran hybrid air vehicles that some of you may know of for a number of years before moving across into the ATI, which I've been running for the last 8 years. So when I started, it was effectively a startup. There were no people, there were no IT systems, etc. So some 8 years in, hopefully we've gained a reputation, but I'm sure some of you may have some questions about that during the panel. In terms of the Aerospace Technology Institute, its focus is very much on commercial aerospace, so we don't fund or focus on anything other than that specifically. We have kind of a threefold purpose. We create a technology strategy for UK aerospace. We drive economic growth through the funding that I'll come to in a second, and we have a convening power, so we bring together the sector, not just within aerospace, but also across aviation and others. It's kind of a result of a unique partnership, I would say. So some of you will have heard of the Aerospace Growth Partnership, a partnership between industry and UK government. Very much the envy of many of our competitors across the world, and I think it is genuinely unique. The ATI itself is also pretty unique in the sense that it's a private company, so most funding is often given through quasi-government or government organisations across the world, but the ATI is very much a private organisation, which gives it some independence and therefore voice, which I think gives it some great strength. Clearly, the board's represented by private individuals, public sector, etc., so it does have a good governance system. The funding is quite significant, so we have £5.8 billion that we have from our inception in 2014 through to 2031, so quite a considerable amount of money. That is match funding, so half of that is government funding, half of that is industry funding. Now, the reason we exist, before the question comes from some of you who are real free market thinkers, is there are lots of market failures in aerospace. One, there's lots of international competition, so everybody wants to have the sector in their nation. And then secondly, the investment returns are very much long-term, so some 15, 20 years to see a return sometimes in the investment. So in terms of the landscape across aerospace, I think it's very much, as Jenny mentioned, in aerospace and aviation context, much more than perhaps it would have been even a few years ago. We have the second largest aerospace sector in the world, just a second to the United States. It's a growing sector. It has a market forecast of some £4.5 billion out to 2050, very much driven by the growth of the middle classes around the world. And despite the pandemic, we still do see it very much as a growth sector. Quite when we get back to 2019 numbers is probably anybody's guess, but having flown a lot recently, I can say it's certainly getting busier again. It has significant challenges, so particularly around sustainability. We represent some 3% of CO2 emissions globally, and obviously that will increase as we increase the number of aircraft flying and as others decarbonise. So the legal target that we have now around net zero by 2050 is very much the number one target that we're focused on. With that said, we are focused on other emissions, so nitrogen oxides and other emissions are really important, so the industry is not forgetting those. CO2 happens to be the largest, but is by no means the only one. So lots of growing competition and disruption in the technology, which is affecting the market. So if I think about the aircraft we look at, from the large twin aisle to the single aisle to the regional to the urban mobility range, all the technologies required to decarbonize them or to make them zero emissions is different. So there's a different mix, which requires huge amounts of investment and lots of challenge. So the viable solutions that we see range from batteries through to hydrogen, be that fuel cells or liquid, hybrids or sustainable aviation fuel. And the exact mix depends on the aircraft size, range and capacity, and therefore makes it very, very difficult. Now, we just completed in March what we called our Fly Zero project, which has been a one-year study looking at the feasibility of zero carbon emission technology. And I was really keen to sponsor that to decide what we should invest in, because if I think even a year ago, it was not obvious that hydrogen was entirely feasible. Now, this was only a feasibility study, but a feasibility study led by 100 experts from across industry and academia. So I have confidence at this stage that it is well worth investigating further. So I think what goes with that then is a need to drive change, not just within aerospace or aviation. It also requires energy production, infrastructure to deliver the hydrogen, etc. So it is a vast challenge for us, not only in the UK, but internationally, because clearly if you don't have the fuel where you're flying to, then it's not much use. So quite a lot of challenges. But we're great. We have some great strengths in the UK, whether it be in academia, in the research institutes, or indeed in the industry. We pretty much cover all of aspects of the aircraft itself. And there are certainly new opportunities in the supply chain. So if I think of hydrogen itself, there is no real hydrogen economy that is supplying all of this or necessarily researching it. So there's lots of opportunity. And for me, that's a new opportunity. So last, before I close and move on, I just wanted to highlight a few kind of critical aspects that I think are required to deliver that. It's not entirely everything, but it's certainly the important ones. I think collaboration and partnership are essential, and it has to be international. It's an international sector. It works that way. It's international today. That's not about to change. And the sheer amount of capital required to deliver this is extreme. I think the investment and development of the entire value chain is essential. So I mentioned energy production, infrastructure. It all has to happen at the same time. We can't wait for one to take the lead. I think new forms of innovation and different approaches to finance are essential, and it can't be done the way we've done in the past. Jenny mentioned certification regulation. We need to be lighter on our feet when it comes to that. And then last but not least, given I'm in the city, I think genuine patient capital is essential. The ESG agenda needs to be lived and breathed, and I would certainly encourage that for any of you who happen to work in finance. Thank you.
Brilliant. Thank you very much. On time as well.
Sorry.
Great. Well, that's a really good kick-off there. So now I'm really delighted to introduce Dr. Marko Bacic. Is that right?
Yeah, that's fine.
Okay.
Yeah.
From Rolls-Royce.
Thank you. Yeah, thank you. My name is Marko Bacic. I'm engineering fellow for control system and gas turbine functionality. Background as a control engineer, and then moved into the whole propulsion system framework and the whole platform level integration systems. I'm today to talk about urban air mobility, but if you allow me, I'm just going to take a couple of minutes to set the scene in terms of what we as Rolls-Royce are doing in the context of overall rebirth of aerospace in particular. So, in the context of the gas turbine itself, we've been developing obviously large gas turbines for quite a number of years, and we've been driving through that development a reduction in not only carbon emissions but also nitrogen oxide emissions and the noise emissions. And the way we were doing that through the partnership with universities, SMEs, cross-sector, and with the support of UK government agencies like the ATI. And obviously we are going to be, and we are currently developing the largest jet engine, the Ultrafan, which will be at least 25% efficient than the first generation of Trents and at least 10% more efficient than the current best-selling Trent XWB. However, these engines are burning currently the kerosene, and so the question becomes, can we try to derive net zero from our emissions from our products? And one way of doing that is to work on a drop in sustainable aviation fuels. Now, there are many ways you can produce a sustainable aviation fuel, net zero fuel. Some of them are bio-derived, which might be competing with the actual food supply chain, so maybe not the best way of deriving sustainable aviation fuel. Others, like power-to-liquid fuels, are more sustainable from that point of view, but require large energy to produce. And they also require things like direct air capture. So if anybody knows in the audience, power-to-liquid fuels, you go from electrolysis and water to generate hydrogen, and then direct air capture through Fischer-Tropsch to actually generate the kerosene that actually get then burnt in the engine. Those fuels are quite energy intensive, and therefore we could provide a second axis in terms of infrastructure, what Gary was talking about, in terms of SMRs, which can provide the energy to create those sustainable aviation fuels. And so that's the sort of second part of the story. Now, the third part is all about the electrification and using novel concepts like hydrogen. We are looking to potentially do a hydrogen-based demonstration somewhere in the middle of the decade for our gas turbines, which will obviously be a zero carbon at source of the gas turbine. And we are looking at novel technologies like electrification for those typical vehicles in the urban air mobility space. You can see on the picture on the left, our Project Axel is an example of pushing the boundaries in terms of what can be achieved with a battery storage system and a single engine aircraft. And that is where we have managed to break the world speed record at 345 miles an hour using our own battery system. And we were able to, write a flight approval sheet for that, which is the key in get the aircraft safe in the air. Building on the back of that, and also the project called EFAN-X, which has finished recently, where we have demonstrated the megawatt class generator and propulsion system. We are looking to expand the knowledge into the urban air mobility sector in terms of the eVTOLs and also in terms of the commuter aircraft. And you can see the eVTOL, which is the vertical aerospace eVTOL vehicle, where we are providing a full powertrain propulsion system. And the idea in those kind of vehicles is to be able to have a zero carbon at source, provided we can achieve the right energy density and the right sort of propulsion system sort of density as well. We have also partnered with Tecnam and Widerøe, which is the Norwegian airline, and you can see the Tecnam aircraft that will be fully electric aircraft that will be flying somewhere in the middle of the decade, or middle of this decade as well. So those are the kind of electrical propulsion systems that are currently we're working on in Rolls-Royce. All that underpinned with the enhanced integration of the systems, and with the full support from BEIS, UKRI, and ATI as well. Finally, I would like to say that as part of all of these new concepts, we are actually reinvigorating aerospace, and therefore the younger generations coming in are getting more excited about aerospace again. So rather than just working in the IT and app environments, we are helping through the through our own involvement with universities and so on to promote the science, engineering, and technology in particular for the aerospace applications. So that's all.
Brilliant.
Thank you.
Okay, thank you very much. That was really interesting. So now hand over to Steve from Airbus.
Thank you, Jenny. Good evening, everyone. My name's Steve Raynes. I work for Airbus. My current role is R&T Business Development and Partnerships, so following in Jenny's footsteps. I'm a structural engineer by trade. I then have moved into running simulation teams, digital twins. Then I ran the test, structural test and materials test across Airbus Europe. And now I'm in the R&T development role. So in that role, I'm building collaborations with industrial partners, academics, HVMCs to deliver the technologies that we need in Airbus for the future. So I'm here to talk about hydrogen, but I was going to set the scene briefly, but Gary and Marko have done a brilliant job of talking about SAF, or the general target. So to hit the aviation targets of net zero in 2050, it's going to require multi-factors. So we can't do it with one. So SAF, it will be a major contributor, certainly in the short term. So most of the Airbus fleet have been already flown on 100% SAF. So we see that as the immediate solution and also the longer term solution for the larger wide body long range aircraft. However, longer term, to get a true net zero, a true zero emissions, shall I say, not net zero, zero emissions aircraft, we are developing a hydrogen aircraft. So what you can see on the slide behind me was the launch of the Zero E program. So we launched that in Airbus in 2020. It's a two-phase. Simplistically, I'll divide it into two phases. So we have the techno brick development. So that's the phase we're in now. So between 2020 and 2026-ish, we'll be developing the technologies and the bricks required for each of the different products you see there. So I'm working closely with ATI, BEIS, UKRI to build those projects to develop the technologies. So that phase of the project runs to about 2026. We'll be then looking for what we call a formal program launch 27-28, where we will down select the technologies and choose one of the options you see there, or it may change between now and then. And then we will go into program mode where we design, test, and certify. So the three aircraft that you can see, there's a turboprop, which is 100-seater, 1,000 nautical mile range. And the other two is, you see the blended wing body, and there's a turbofan. They're both 150 seats, 150 to 200 seats and 2,000 nautical mile range. Probably why hydrogen? So hydrogen, we've looked at various fuel types. So we've looked at gaseous hydrogen, volumes way too large for the energy. Pressurized hydrogen, which is an improvement but still doesn't give you the range. So we've moved towards cryogenic hydrogen. So if you compare 1 litre of kerosene, the equivalent in cryogenic hydrogen, you need 4 litres of hydrogen. So you can immediately see why you get a potential range impact. Some of the other fuels we've looked at we've looked at ammonia. Some might say that's easier to implement, but it's heavier, so it has a greater range impact, and it's also toxic. So we've looked at batteries, but batteries just doesn't have the energy density. So cryogenic hydrogen is the route we're going on. Now, with that, comes many technical challenges. So starting from storage, where do you store it? So traditionally in aircraft, the kerosene's in the wings. You can't store cryogenic hydrogen in pressurized tanks in the wings. You end up with way too much weight. So we've looked at storage of pods on wings, tanks within the fuselage. It's interesting that the Fly Zero project that Gary was talking about has ended up with a recommendation which is close to the route we're going in. It's slightly different, but it's nice to have that independent verification of the direction. So tank storage is a challenge. Is it metallic? Is it composite? Clearly, if it needs to be cryogenic, which is minus 253 degrees Celsius, there's some challenges. Then we move on to the distribution system. So you've pipework, gauging, distribution, pumps. That has the challenges of how do you design that technology, but also how do you integrate it into a structure? How do you insulate the temperature from the structure when you need to get the fuel to the propulsion units which are in the wings, which are quite flexible. So you need a flexible system at minus 253 degrees Celsius. So there's some challenges there. And then we come into the overall propulsion system. So we've got some choices there. You can use hydrogen in two ways or a hybrid way. So it's either direct combustion, so converting a traditional combustion engine with different injectors to burn hydrogen directly, or you put the hydrogen through a fuel cell, generate electricity, and use e-motors. We're also heavily focusing on hybrid option. So you have the direct combustion with the e-motors, so it gives you different power demands at different parts of the flight. So you need high power demands during takeoff, but less so in the cruise, and so you can tune the systems quite cleverly. So lots happening. It's actually very interesting for, I think, younger engineers to see the landscape changing so quickly, with many opportunities to work with, I think, new names, smaller companies, new names that we haven't traditionally worked with in the past. It's exciting times.
Thanks very much. That's great. So now, delighted to welcome Yoge from Blue Bear.
Jenny, thank you, and good evening all. Delighted to be here. So, Steve mentions new companies and different types of companies. We are one of those different types of companies. Quite unusual. We're an SME, less than 100 people at this point in time, and we are renowned as an agile systems integrator. So, let me introduce myself. What's my background? I am chief exec, still very techie. So I run Blue Bear, 22 years in operation, still techie. My background is avionics engineering by education, aerospace, PhD, and 11 glorious years in government labs where I did everything from blue skies research to what was then taking aircraft into service and certification release into service. So very, very lucky and privileged to work across that low TRL right through to high TRL. Programs of note that I've mentioned that actually play into today's conversation is I worked on the Harrier jump jet, how to transition from airborne to ship landing deck modes. I helped down select JSF, the lift fan concepts that came around with Boeing and Lockheed Martin, and had some great times looking at new approaches to certify. How do, Tornado was 4 sheets of A4 for flight control system, Typhoon is half a roll of wallpaper. How do you certify that? And so model-based certification. Now, let me talk a little bit about the topic, Blue Bear. Blue Bear, renowned for automation and autonomy, predominantly in the military world. So when it comes to air autonomy, Blue Bear dominate the UK, be it singleton aircraft or multiple swarms. We, though, as a company, have been really waiting for that civil market to wake up, the urban air mobility market. I've been talking about flying taxis for 25 years. So here we are now. So what have we done, Blue Bear? In the last 2 years, we have won almost £20 million worth of work on civil applications, where we're now busy reading across all the tech that we've developed in military world to help then automate, in particular, the regional transport routes in the UK, so end-to-end, doorstep to doorstep. That's on a project that's called Future Flight, and it's a project called HEART. But today, here and now, I'm going to talk about the other exciting project that we have, which is all to do with electrification. And we talk about more electric aircraft. Jenny asked me, do I want to talk about electric aircraft or more? It's more. More because, we've been looking at more electric aircraft for quite a few decades now, whereby we've been taking weight and inefficiencies out of aircraft by replacing what were old, now considered slightly older, pneumatic systems, hydraulic systems, and replacing them with more lightweight systems. That was very much focused on non-propulsive elements. The focus for now in Blue Bear is how do you take that more electric form to propulsion systems. So what you see up there is something called the Integrated Propulsion Module. It's designed to be scalable and modular, and the markets that we're targeting are there. It's on the top. Let me just see which way it is. On the top left, it's delivery. So Amazon Prime, for example, absolutely interested in what one could do with this sort of engine. On the top right, regional aircraft, 20 passengers perhaps. On the bottom left, it's heavy load lift. Bottom left, it's air taxis. So what we're producing is a very scalable and modular concept. The scalability helps. Jenny mentioned the challenge of certification and how it is. This is not just about the design and rollout of an engine that is more electric, but it is very much about taking the community along on a journey of how you may certify this article, starting with something small where the market is ready, and then ending up with something really rather large. Now, this engine, we've got integrated in front of it. What does that mean? Everything in that engine has to offer efficiency. It's not an all-electric aircraft that we'll be looking at in the near term. We will be looking at hybrid solutions. So what generates the electricity to begin with is not, we are agnostic to. So it can be hydrogen fuel cells, it can be gas turbine sources, it can be batteries if batteries come to that stage. A core part of that engine's job is really to create thrust very efficiently from that source of electric energy. How do we see the future mapping out? Well, here we are producing engines. I've talked about the background and the heritage that is in Blue Bear, companies like Blue Bear. We are a nation that designed the Harrier jump jet. We as a nation could actually design more integrated aircraft. So rather than the idea that you can just retrofit engines onto existing aircraft, we in the UK have a capability to design aircraft from scratch and design very efficient, more integrated aircraft. So if I were to put down what would I like to see the future to be by 2035, is the UK actually leading on this topic and making good use of its heritage. We have not just some of the best designers in the UK, we have one of the best aviation authorities, which is very well respected around the world. I end my note on saying, as a company, we talk about the age demographics. We're a very lively company. We've got a lot of youngsters from 20 to 60, and we love it.
Great.
Thank you.
Thank you very much. And lastly, I'm delighted to welcome Miles Gray from BEIS to have a bit of a background on the government policy.
Thank you. So you've heard the brains, now you hear from the bureaucrats. So BEIS, Department for Business, Energy and Industrial Strategy, used to be I'm going to get this wrong, Department for Trade and Industry. And Shelley used to be one of my predecessors, so it's good that they don't lock us up at the end of their careers. You've heard all the great things that aerospace does, and you've heard all the really exciting stuff, the great whizzy ideas, the fantastic innovation that's being driven, the energy, the depth of knowledge. That's absolutely fantastic. I'm going to tell you the boring stuff about how we try and make the choices about what we want to fund in all of this. Because if you hear them talk, you just want to give them, you want to support them because they're great ideas. So aerospace clearly drives growth. That's fantastic. We love growth. It doubles every 15 years, give or take a COVID intervention. That's fantastic. Lots of jobs, well-paid jobs, nice spillovers, helps with those nice combat air systems as well that we want. It's a super strategically important economic sector. And we want to drive that growth. That's one of the reasons why we want to carry on funding innovation. We think innovation is the best way to support that growth. That's where we think the market failures that Gary mentioned bite the hardest. So we're very much about co-investment, co-investing alongside industry. So making sure that we're investing in stuff that industry has some skin in the game. It's more likely to lead to a market outcome that we want. I don't just want growth. We also have to have clean growth. We have to tackle emissions. The emissions aren't huge at the moment, 2 or 3% of global CO2 emissions. Kerosene is hard to replace. So it looks like one of the more difficult sectors to decarbonise alongside stuff like marine. If we don't tackle it and all the other sectors do, it just looks like a bigger and bigger problem as time passes. So we think there's fundamentally 4 ways to try and tackle or decarbonise aerospace. Very broadly, sustainable aviation fuels you've heard mentioned, new technology, either to make existing technology more efficient or to replace it with zero emissions technology. There's certainly things you can do to improve operational efficiency, both the management of airports and the management of flight paths of aircraft. And then fourthly, there's of course going to be some market-based measures. We already have an emissions tax system, trading scheme out there. Potentially there's regulation. I think our preference is, let's see if we can make sustainable aviation fuels and zero emissions or new technology work before we have to pull that lever to reduce demand. And it's a race to see, can we bring that, both increase the supply of SAF fuels and bring technology to market that will reduce emissions before we pull that lever. And it's a delicate dance for government to play. We'll set this all out in a lot more detail towards the end of this year when we publish the Jet Zero strategy. Snappy title. Should set out, I hope, how we balance all of these different levers. To be honest, we have no real clue, and it's very much going to be a case of adjusting them as we assess the effect. So what does success look like for me? It's a sector that we're growing, we're increasing our market share if we can, but certainly securing our market share in a growing market. It's a sector that's reducing its emissions at the same time. And beneath that, what does success look like? So it's UK leadership. We really want to keep the primes here. I can't think of any sort of aerospace nation that hasn't got several primes located here. So keeping Airbus and Rolls-Royce here is super important to us. But it's not just about primes. We want to broaden and grow that supply chain that surrounds them. I know all of the companies here today, including Yoge, work with a whole network of different suppliers, from very large to very small, and we want to broaden and deepen that supply chain. That's super important for us. And that supply chain is the place where all those crossovers happen. Many of those small companies aren't just aerospace companies, they do myriad engineering sectors. And finally, I want to embrace those disruptors. So there's disruptive companies out there. Some have been mentioned, Vertical. There's another company that's Zero Avia that's messing about with hydrogen propulsion systems. Aerospace is a super sporty business. I know it has big barriers to entry and has been super consolidated over time. But there's always a chance that there's some big disruptor comes in there. I think we have to cover that bet. So putting a portion of our money to try and focus on those disruptors, those SMEs, is super important to me. So those are the 3 things that I want would be a success for me. And at the end of it, it would be, a bigger sector that's well-paid jobs, mostly outside London, huge amount of innovation, driving lots of positive spillovers, reducing emissions, and importantly, unlocking the ability for people to continue flying. The benefits of flying are great. Connectivity, trade, and frankly, people enjoy it. It makes them happy. As soon as they get any money, they want to go on holiday, they want to go and visit their friends. Super important. If UK innovation and technology can enable that, that would be a great success for me. Thank you.
Great. Thank you very much. And well done, everyone. Right, well, we've had a good romp through through the aviation and aerospace sector, haven't we? I think that's been really quite fascinating, and hopefully you've all found it interesting. We'd very much like to have your questions now. We have got roving mics, and a point's being made is, as I mentioned before, we are recording this, so if you can wait until you get a mic, it means you'll be recorded. Maybe if you don't want to be recorded, go straight ahead. But so very happy to take any questions. I saw one hand, that number 1, number 2, and number 3. But sorry, no, you're number 1. Oh, sorry,
I got the wrong number 1.
That's number 1. And
am I number 1? Or?
You're number 1. So fire ahead.
Thank you. Barry Brooks, past master engineer, and have a vested interest in hydrogen. So I was very pleased to hear all of you implying that hydrogen is going to be the answer, even if it's in hybrid situations, which is great news. It's going to create a demand, but where is the effort, and perhaps I look at BEIS and the government here, to make sure that hydrogen will be there and the infrastructure will be there where the aircraft, the ships, the cars are going to be. So a new fuel, but how are we going to make sure it's there to match the timescale against which you're developing all these technical solutions to burn it?
Okay, do you want to have a go first then, Miles?
I'm happy to have a go first. So it's a great question, Barry, thank you. I don't really have the answer. BEIS has got a hydrogen strategy, which it published earlier this year, which set out a higher target for the production of hydrogen, which bakes into it the demand for hydrogen for aerospace based on Gary's excellent Fly Zero report. We don't know. No one knows what the cost of hydrogen production is going to be, and it could be that actually power to liquid fuels or synthetic fuels could be better. Maybe carbon capture and storage might be the answer and could be even more cost effective. I don't think anyone knows, and I don't think we can afford to take a bet on any particular one. So it's a slightly balanced strategy, and it's looking at other uses for hydrogen, including home heating, which may or may not work. I think we've probably got 5 years to decide whether we want to go down that particular road. So we've set out how we're trying to balance those different priorities. Well, it's hugely uncertain, and I think all we can do is try and maintain that coordination, keep looking at the balance across the whole energy vectors piece, and try and stay nimble and connected as we can. Is that a rubbish answer?
No, I don't know whether you've got anything to add.
I was just going to add that you completely agree. I mean, it's I guess the biggest risk for us is you've got to have the hydrogen available at both ends, and it's not something that traditionally Airbus gets involved in. You know, we develop the aircraft assuming the fuel's there, but this is a bit of a step change. So we have launched quite a few projects now to try to simulate that infrastructure learning. So we've been working with several airports across Europe and also other industries. So we're trying to develop a cross-sector approach along the lines of what Miles has said to stimulate the learning. So we've got an idea around an airport hub model for hydrogen, because normally as a starting point of a hydrogen distribution, airports typically have very good infrastructure links, whether it's road, rail networks. So it could be a good starting point for wherever you start producing hydrogen. It could be, let's develop at the aircraft at the airports first, and then grow from there. But yes, we're keen to be involved to stimulate that side of things.
Right.
Yeah, go on, Mark.
Yeah, so from a Rolls-Royce perspective, obviously, to create hydrogen, you have to do the electrolysis, and to do electrolysis, you need electricity, right? And from the Rolls-Royce perspective, where we can play the role is in the SMR business side of things, yeah, because every SMR gives you 440 megawatts, and just to give you the kind of numbers is required to create the amount of hydrogen needed to fly aircraft. If I take maybe first six flights from London Heathrow, actually about 5 to 6 flights out of the top 10 per passenger kilometers across the whole world take off from London Heathrow. So there's a London to New York and so on. The kind of number of gigawatts you need is of order of 20 gigawatts or so. So you can see that the number of SMRs you need is quite significant. And obviously Rolls-Royce is ready to provide those.
Great. Okay, have you still got the microphone?
Sorry, my question led actually into what you've just said. This needs to be an integration, not just with the aviation industry, but with the whole of the transport industry and the energy industry. And I must confess, Mr. BEIS, I wasn't convinced by the government's energy strategy in how we're going to get all that power generation, such as the SMRs. That's just one example. So it's a system of systems which needs somebody to lead it.
Thank you. Right, I think you were... Thank you for that. Let's have the next question.
Hi, Kate Barnard, ex-Rolls-Royce. Kate Barnard, ex-Rolls-Royce, now entrepreneur. A bit of a wild card question, actually. I've done some travelling recently and just done 2 flights to Australia, which is like 15 hours plus 7 hours. In a one is a real long way. And recently there was an announcement to say that they could go from London to Sydney or New York to Sydney in one go in 19 and a half hours, I think it was. Mm-hmm. But there was also some things on the technical aspects of, there's an environmental aspects from emissions, there's a public perception for getting on 2 flights is really difficult, taking off and landing, I don't really enjoy it. And then the technical aspect as well of building a plane to do that. And it's quite an emotive topic, so really I wanted to see what the opinions of the panel were for that.
Do you want, as it was a A3?
Yes, it was.
15.
That's a curveball, that one.
Yes,
Yeah.
It's very topical.
Well, it is, and I think it's there's a personal aspect to it. I think it would take a certain individual, I think, to be happy with an 18-hour trip, but there's been quite a lot of work to say, would people do that? There is an environmental impact, as you say, because you remove one of the takeoffs, which burns a huge amount of energy to get up to altitude. But the feedback is there is a demand for that. Personally, I'm not sure I'd be in that camp yet. But as a business, if there's a demand for it, we'll deliver the aircraft.
Great. Anyone?
Happy to comment. Yeah, happy to comment if that's right.
No,
No, I think the thing I would add is I don't think the sector is honest and open about the challenges it has and the opportunities that go with it, as it should be. And given transparency in the internet and the youth is focused on the environment, someday it's going to happen to us unless we take a lead. So for me, we need to step up a gear and be much more transparent. I certainly have, I won't embarrass Steve, but I have some calculations that we've done internally in relation to that particular flight, and it isn't always as perceived in terms of its environmental impact. Yeah, well, exactly. But so I think in terms of being much more transparent about it, because everyone will find out eventually, and I know the impact. I don't go around shouting about the actual impact yet because it would frighten the horses. But I think we shouldn't shy away from it because ultimately it'll get found out. And secondly, it's exciting, right? So if you're excited about technology development and making a difference whilst connecting people, to Miles's point, then join in. You know, it's more exciting than it's ever been, and you know, I've been doing this for over 25 years, and you know, it's not often these type of new developments come along. So come and join and help out.
Right, thanks. Right, we had another question just here. Man with the mic.
Simon Howison, retired engineering director, BAE Systems. I'm sort of interested in the economics of this rather than the technology. If I look at cars, it seems to me if you strip all the tax off diesel and petrol, the price of energy to move your vehicle is about the same for petrol, diesel or electric. And the carbon footprint rather depends how you generate your electricity. If it comes off wind, well, it's clearly good. If it comes off a gas turbine, I suspect it actually is about twice the carbon footprint that you would get out of a petrol engine because of the distribution losses in getting the electric to your car. So I'm interested in hydrogen in rough orders here, understanding nobody knows exactly what hydrogen would cost to get into an aeroplane, but is it going to be a similar sort of price to kerosene, or are we looking at something that's going to be 10 times as expensive or 50 times as expensive? Because it's quite hard to see how an aviation industry would actually operate if the fuel costs 10 times what it does now.
Go on, Marko.
Okay, so rather than talking in pounds or dollars, I'm going to talk in megajoules per passenger kilometre, as that's the sort of basic engineers talk, right? So from the perspective of kerosene, the pure today's XWB, you are looking at around 0.7, 0.8 megajoules per passenger kilometre. Okay. Now, obviously, the kerosene being burned is creating CO2. So you have two options. You either decide to go down the route of a Fly Zero or Airbus 0E, where you have a hydrogen aircraft. Now, those hydrogen aircraft are going to be heavier. There is no question about it. They will carry fewer passengers, and as a result, the energy usage will go up. We think of order, instead of 0.7, you're looking at about 1 megajoule per passenger kilometre of that sort of 1.2 megajoule per passenger kilometre. However, if you were to then use the sustainable aviation fuel, then you need to take into account that apart from the electrolysis front end where you generate hydrogen, you then need to spend some energy to take out the carbon out of the atmosphere, which then costs you, in this case, 9 gigajoules per ton of CO2, for example. So when you bake all that into the equation, you come down to the numbers that are looking around about 2.5 megajoules of electricity per passenger kilometer for sustainable aviation fuel, and around the same 2 megajoules per passenger kilometer of electricity for the hydrogen-based aircraft. Okay, and the numbers at the moment at this distance, unless I built one, and this is with a kerosene aircraft having, 70 years worth of development. Okay, so if I were to compare like for like, just in a basic sums way, then you're looking at roughly within plus minus 20% either way. So the jury is out, and that fundamentally the majority of the cost is in the energy cost anyway. So in terms of pricing, you are looking at pricing that is roughly around that, maybe plus minus 20%, and probably a bit more for the SAF anyway because of the extra stuff you need to do in terms of carbon capture. So that's really where we are in that respect. One gives you net zero, the other one gives you zero carbon at source, hydrogen versus SAF. But obviously we have to move away from pure kerosene digging out from the ground, because obviously that is the cheapest and that's the status quo. And if we want to reduce the carbon emissions, we have to either introduce SAF, and we also follow a second line of inquiry, which is the hydrogen itself. But in terms of just the basic, pricing, you are at this distance until I built one hydrogen aircraft, you are looking at plus minus 20%. When I go further into the future, if I keep developing hydrogen aircraft, I might be able to get it down to 30% less. And that's where we are really. And it's trying to challenge that inertia of just having status quo, just having horse and cart, rather than a car.
Do you want to?
I can't beat that answer.
No. Okay. Right. Let's.
Sorry.
Okay.
Well, all I could add is that on our website, having completed the Fly Zero project, there are a lot of detailed reports. So for those of you who are interested in looking at the analysis and the conclusions that are largely consistent with Marko's analysis, then please read them. You can simply download them, and it has all of that it's considered all of the economics and the challenges that go with it. And for me, it's only the tip of the iceberg. You know, the question is, having uncovered what we did uncover, how do we now use that as a conclusion to invest and succeed and take a lead from the UK's perspective? So please have a read. You know, it's very interesting inputs, and including some of your old colleagues, Simon, will have participated as well. So.
Thanks. Sorry, just very briefly, because annoyingly, Barry and Simon have picked up on really difficult issues that we really can't answer. I guess the assumption is, can we continue with kerosene not having any tax on it? I think that might be more difficult. So if we assume that it does have some global tax on it, and that's a huge challenge, that might make hydrogen more attractive. I think hydrogen as a feedstock for SAF immediately makes you think SAF is always likely to be more expensive than hydrogen. It really depends on the price of carbon capture and storage, and no one knows what that is. I've heard some entertaining claims. So it's possible in some scenarios, and Gary's report sets this out brilliantly, that hydrogen potentially could be cheaper than kerosene by around 2030, but who knows?
Thanks very much. Gentleman right at the back. And then...
John Chandler, Engineers Company. My question is in two parts, but it is one question. You panels quite rightly concentrated on the power source for aviation. What role does aircraft design in terms of aerodynamics, structures, systems, obviously electric replacing my colleague? And secondly, in the way of aircraft operation and traffic, for example, we're now going point to point with smaller aircraft rather than hub and spoke with big ones and Airbus. About that.
Maybe I could take the first point. The impact of hydrogen and the new propulsion units on the design of the aircraft actually is freeing up quite a lot of the design. So traditionally, the wing has been a fuel tank. As we move to hydrogen as a power source, the tanks aren't going to be in the wing. They might be in pods, but it immediately frees up your design space. So it's an interesting conundrum almost, because we've been designing wings in exactly the same way to be fuel tanks since the year dot, and suddenly they're no longer fuel tanks. So our configuration within the wing can be entirely different. What we are already looking at, so we've had a project that's run for a number of years around, that's called Wing of Tomorrow, which is looking at introducing composite manufacture at rate into a wing. But now when we introduce the fact that it could be a dry wing, one, can we manufacture the wing in a different way? Two, it also means is what do we do with the space? So it's you don't want to have wasted space on an aircraft, and what do you use it for? So we've also got some additional challenges that we use fuel within the aircraft. We pump it around and use it for load alleviation, so you can move the fuel to the outer part of the wing to help reduce your loads in the wing. Well, if you haven't got fuel in the wing to do that, how do you potentially alleviate your load? So you may have seen, if you look on YouTube and look at a project called Albatross 1, where we're looking at ways of reducing the wing and the load in the outer part of the wing through something called it's a semi-aeroelastic hinge. So the wing hinges at the outer part, and that vastly reduces the outer loads. And then there's other things that you might have seen on gliders. You see pop-up spoilers, which we haven't used on commercial aircraft. But so there's a lot of technologies that have been put back onto the table because you've now got a dry wing. So that's part of the answer. But it probably goes wider than that, because we then need to consider. I think I said it earlier that you've got cryogenic systems attached to your structure and your flexible structure. So that gives us some challenges we need to deal with.
So if I were to answer that question from an air taxi for urban air mobility point of view, it is quite remarkable what we see as new configurations that the world is producing. It's even 10 years ago, we would have had very conventional design coming out. Now, we've got weird and wacky blended wing structures. We've got thrust generators in different places, smaller thrust generators distributed. So it does open up some design freedoms in terms of how we design what we design. And that may help with how we take off and land, for example, and the spaces that we need to take off and land. But it will also pose challenges in terms of then, okay, so we've now got a completely new structure. So the conventional methods that we had to design and to certify may now need to be rethought. So some opportunities, but also challenges. But exciting that we could do things differently.
I think you also questioned about air traffic management and operation. And I mean, I am aware of a number of discussions and activities that have been looking at this. So proper point-to-point, no cruising around over Heathrow waiting for your landing slot, but when you take off, you know what time you're landing and you go directly to it. Very huge opportunities there. A colleague has been going on about aircraft flying in formation. I know when I sit in my back garden, which is sort of on one of the main routes, seems to be out of West Europe, the numbers of aircraft that are flying at all different heights. If they flew in formation, there could be significant benefits. We're not quite there yet, but they are things that should and are being looked at. That
we did do some test flights last year with flying A350s in formation. And three of them in your traditional sort of goose V, and the aircraft don't need to be, they don't need to be 6 inches off the plane in front. You need to be within a kilometre, and you get the benefit. And we've been looking at, okay, how do you then introduce that into the fleet, because clearly the lead aircraft doesn't get any benefit and all the ones behind do, so you need to build a business model into it. Plus you need to then consider, okay, you've got to have a really slick air traffic control at Heathrow, which means you have to take off within close time and get into formation quickly. So if you don't want to be faffing around for half an hour getting into formation, it sort of defeats the purpose.
So the Treasury is funding work in this area also. So there's an Industrial Challenge Strategy Fund, Future Flight, that is looking at what should airspace of the future look like, for everything from point to point to hub and spoke. So there are experiments running with mixing what might be very conventional air traffic management systems today with what might be future urban air mobility traffic management systems, where it's not necessarily nationally controlled either. There may be regional handovers and very much sort of pop-up centres that do traffic management.
Don't want to sound insecure, but we're funding
that. Well done, Miles.
Okay, we did have you had a question. You have.
Thank you.
And you've got the microphone.
Is this working?
More important. Yep.
Yes. Nick Goodwin from the Air Pilots.
I think this is going to be probably the last but one. So someone better have a really good question for the last one.
That takes the pressure off me then. Thank you very much. Nick Goodwin from the Air Pilots. Clearly, we advocate air travel. We advocate the role of pilots and safety in airborne management. My question is this. If I've heard correctly from all of the panel, who've been brilliant in their descriptions tonight of the technologies they're looking at, the one thing that I think has been apparent is that we are talking about near, medium, or short or medium haul. And we know that the government strategies to 2050, be it carbon zero or jet zero, recognises that long haul is not in that focus, because long haul is covered by international agreements, not by national agreements. Would the panel feel freer if they were able to actually challenge that, if you like, elephant in the room, which is long haul? You know, and we all know, that other, even in Europe, governments have addressed that. For example, France has identified that they will not do domestic travel by air because they see that there are better opportunities. We clearly advocate the whole aviation system. how do we actually progress the technologies you're talking about that are constrained by the medium and short haul to actually go to that long haul, which I think another questionnaire asked, which is what we all so much enjoy without the penalties of costs that would be prohibitive. Thank you.
Yeah.
Yeah, well, certainly, again, sorry to harp on about the Fly Zero project, but we concluded that long-haul aircraft, wide-body aircraft, could fly over 5,000 nautical miles, so pretty much get everywhere one stop using hydrogen, obviously. So we were very much advocating that we could impact that, and probably, I think, through UK technology, impact over 30% of the CO2 reduction internationally because of technology from the UK. So I think the opportunity is there. I guess the challenge, again, without putting Steve on the spot here, is it's largely driven by two aircraft producers. They decide when they want to do the next generation aircraft. So Boeing and Airbus, when they decide the market is there and the technology is right, will release the next generation aircraft. And from my perspective, Fly Zero was trying to influence them both as best I can from my little position here in the UK, but at least identify that it is doable, and we shouldn't avoid your point that these aircraft are the largest CO2 emitters and having the biggest impact. So again, back to the point I said earlier, we shouldn't avoid it. Everybody, certainly in the industry, knows about it, so we better just get on with it and find a solution, as far as I'm concerned.
I think it was, what I would say, it was promising to read the conclusions from the Fly Zero report, which indicates you can go further on hydrogen. Clearly, it's a new technology. We've got a lot of work to get it to the standards required for aviation, taking it from automotive and making it lighter and safer and more reliable. So we're playing the route of the simplest way to implement it, which is one of the three configurations I said. But once that's matured and we really understand what the next steps are, then who knows? At the moment, it's really difficult to say.
One small point. Nick, it's a really good question. On the short flights, absolutely you could ban them. Does it really make much difference to emissions? Probably not. It's a nice announcement, though. What would be even better? I think it's possibly, Steve and Marko might tell me better, but you could have a zero emissions regional plane with 20 seats. That could be hybrid electric. That could be truly zero emissions by 2030 or maybe slightly sooner. And that might be a more exciting way of dealing with that.
Right, last question here. Sorry.
Thank you, panel. I'm Mark Jeffers from Rolls-Royce. I'm head of academic collaboration. I'm going to pick up an observation on something that Miles said earlier on and then draw that into a question, if I may. You said, I think it was you, Miles, that said there are lots of technologies and we're trying to back a lot of them. That's an interesting challenge for industry because that's quite unaffordable, actually. And how are we going to pick which ones it's going to be? Because the industry is in quite a difficult time, as is obvious because of COVID. But even so, it's quite a difficult challenge to back lots of horses in one go. And all the big companies will face this problem. I'm going to pick up a question on infrastructure in the UK, because I worry that the UK will lose its place against some of the emerging competition. Healthy competition from the US, emerging competition from China, all sorts of competition around the world. I want to talk about infrastructure in the UK and how we think we can protect that and make sure it's available to not just the big prime, but the emerging companies, the Blue Bears, the others, the verticals and all the rest, that they can access it. A lot of the infrastructure we've used to build the industry we have dates from maybe the 70s or 80s or possibly earlier or later, but it's still getting quite old now. So are we investing in that? And do the panel think that we do have the infrastructure we need to maintain the UK's position in the aerospace?
Kind of a quick initial go. It's a really difficult question. Thank you for asking it. So choosing which technology, you're right, we can't afford everything. We've funded everyone on this table, but we can't afford everything. So what's my go-to when we're making decisions on what we can afford? We do a little cost-benefit analysis. The excellent ATI give us some advice on, is there a market for this? Is this technically feasible? And we add all those factors up. And what's really driving me is, what's the amount of growth I get over the period once the new product comes to market, and what's the emissions reductions that I can make. I put them in a list and we try and pick the best. I try and bring some balance to that portfolio because we just don't want to keep bagging Rolls-Royce. I mean, Rolls-Royce is fantastic, but there are disruptors around.
Other companies are available.
Exactly, and something like that, they're fantastic. So you've got to make that choice. How do you balance that? So it's typical portfolio management based around what gives you the most growth, what gives you the most, what gives you the biggest impact on emissions. And on infrastructure, of course, we don't fund enough. It's all upstream stuff. There's always more urgent stuff that you want to do. Carving out a chunk of your annual budget to fund infrastructure, really difficult. But we have, over the last 10 years, since the ATI program started, 150 million a year, we have managed to refresh a lot of the infrastructure, some of the infrastructure, not all of it. So, for example, the Loughborough Combustion Centre, which is fantastic and a brilliant model of industry, academia, working together with open access, loads of entertaining companies using that. You've got several of those examples. So some progress, enough? Probably not. But thanks for the difficult question.
So can I have a little go at answering this? Because in 2019, Blue Bear phase one of Loyal Wingman programme, build something that's design something that's between 4 to 5 tons, works like a fast jet but is unmanned, and it's a Loyal Wingman to the fast jets. We had the opportunity to say what infrastructure. Design is only 5% of the cost, but it influences so much of what the infrastructure that you need, and the hefty investment is in infrastructure. But what we did realise is, the UK is, again, funding and backing through things like the advanced manufacturing centres, a lot of new ways of perhaps thinking about how you may design. Factory of the future came up a lot. And that factory of the future actually looks very different to today's factory. So new industries and new ways of doing business do follow new designs. So the question, I haven't got an answer, but I have got an intriguing question which says, when do these factories of the future kick in? BAE's got a factory of the future being set up north. When does it kick in, and when do we start using this? And will it transition the aerospace industry like it's transitioned the car industry? Will it do that eventually? In 100 years, will it look very different?
Yeah, from my perspective, I think simply we're going to have to make choices, right? So we have more choices than we've ever had given this next generation technology. So bluntly speaking, we're going to have to make choices, whether we look at that through a technology lens, an economic lens, et cetera, et cetera. It'll have to be a combination of all of the above. But I would also say that, I said it earlier on, international collaboration is essential, and, the aviation sector works that way. So in making those choices, sometimes we will have to partner with others to achieve that. And we shouldn't be afraid of that, because there is no way we can afford or have the capability to do everything, despite me being ambitious for the UK. So I think, we just have to do more of that and be smart about the choices that we make in doing that. And again, I think that's exciting. Collaboration is exciting. It's always worked that way in aerospace, and I don't see it changing, despite some of the challenges we currently face, whether it be the Ukraine or supply chain challenges. I think it's only going to get greater because the challenge is huge. And if we want to hit 2050, we better speed up.
Okay, so I've now got the nice role of trying to do some concluding remarks. I think when Audrey first approached me, and probably everybody else here, the sort of, what was it going to feel like? I think, in a way, that you could feel that things were very depressed. That the impact of the pandemic on aviation has been really bad. But in actual fact, I think in lots of ways it's been quite positive, because it's made people stop and think, and an awful lot of the sort of innovations and stuff that we've talked about really have come as a result of this stop, think, are we going to carry on or not? Do we just, yes, we are. And I found it very encouraging that lots of the issues that I thought there were, we've talked about. We seem to know what a lot of the issues are now, and are actually doing things about it. One of the biggest things that I've seen is this whole I think everybody's used the word partnerships and working together, and I think that's probably the most extraordinary thing that's happening now. The big companies working with the small companies, and really coming together in a very sort of positive way. I think it's great to hear about what we're doing in the UK for the UK and recognising our capability. It's great to think that we might actually be bigger in the UK than we were 10 years ago. I can remember when I was sort of doing Steve's job and working with, I think it was called the DTI then, but how we were really in the doldrums there and really thinking we're just not spending enough on technology. And then look at where we are now, and look at what we're thinking of in the future. I mean, I did warn Steve. I noticed yesterday that Airbus announced that they're looking to increase the production rate for the short-range aircraft, the A320 family, and that's going to be 6,000 new jobs, 600 new jobs at Broughton. I was reminded that they would, of course, be using SAF, so they would be all right. But suddenly things are kicking in and taking off, and it really feels to me as though we've got a lot of technologies and good working and whatever coming through that's actually going to sort of take us forward in a very positive way. So I feel quite sort of optimistic over what we've said. I think we're maybe some rose-tinted spectacles on some of the challenges, but I think the results, I thought the Fly Zero report was fantastic to say, right, I was quite dubious about that programme myself in the early days because it was going to be so difficult, all these people working together remotely, thinking up some, fantastically new things. Yet they seem to have come up with, some real concrete stuff and really good evidence and commitment. And it seems to me that the UK's really got somewhere to go now, and that people are actually singing from the same song sheet here, which is great. So thank you, panel. Thank you for everything. I'd like to call upon Charles, Charles, to do the vote of thanks. Thank you.
Against Jeffrey Epstein. So my task is time actually. We're good. So well ranged, Chairman. So the evening, what a wonderful evening it's been. It reminds me, some of the questions and the answers reminds me of Winston Churchill when he went back to his old school. And not talking about sitting in the front row or the back row. And the headmaster had the whole school there in the gym. And during the headmaster's talk, welcoming the great man, in his old age, he pointed to a line on the wall. And he said, boys, he said, during Winston's life, he's a great drinker. And if you added up everything he's drunk, it would go up to there. And huge, this is all stuff that boys love to know about. So the great man stood up and he looked at the line, and then he looked up the top and he said, so much to do and so little time in which to do it. I feel slightly that this evening has whether rose-tinted lenses or not, it has indicated there's a heck of a lot to do, and we ain't got much time to do it. And we talk about innovation plus all the certification on top of that to come, and one always wants to concertina this into a much shorter time. But that's the reality of how it is. But yes, what an evening, and thank you very much, the panel, for putting it on and taking the time to come here. And being both informative and interesting. So Miles, thank you for answering those difficult questions. I think every question you answered was a difficult one. Yoge, Steve, obviously, Jenny for being such a wonderful chairman, Marko for his megajoules, which I can never forget now, and Gary for his insights on what's happening and where we should be going in the future. I'm also, so thank you very much indeed. Can I give a quick round of applause? I'd also like to thank for tonight's invitation Audrey, the master of the Worshipful Company of Engineers, for the past week. So congratulations to you for your instalment 1 week ago. Together with the Worshipful Company of Insurers, the Air Pilots, and we have both the master and the past master here this evening, and the Worshipful Company of Scientific Instrument Makers, which I'm a representative. And we do have a few more wearing similar ties, I think, this evening, which is nice to see. but especially this evening could not have been the same without this wonderful audience. So thank you very much for coming and for making it alive with perceptive questions and insights for the panel. I think wrapping up, I have to say that all this talking gives a terrible thirst. And I gather that there are some drinks over there. So please do stay on and have a chat with the panel and everyone else. Thank you very much.